Hi, grade 12. So I quickly want to do a video about deriving from first principle. So when we do the derivative from first principle, we have to remember that the formula for first principle is when the derivative of x is equals to the limit as h approaches 0 in our formula for f of x plus h minus f of x all over h. So that's the formula that we use if we look at the derivative from first principle. Okay, so now we're going to do an example where we have to do or we have to derive from first principles the following: f of x equals to 1 plus x squared. So by looking at this formula, we know that we need an f of x plus h and an f of x. This is found on your formula sheet, just as a reminder. So the first thing that we're going to do is, since we need f of x plus h, I have the formula for f of x, and I am now going to substitute x plus h into x's place, which means anywhere in my formula where I have an x, I need to replace it with x plus h. So now we're going to do 1 plus bracket x plus h squared. All right. So now we need to simplify this. And just as a reminder how we simplify a bracket that is squared, I'm going to go plus x squared. So I square my first term. Then I take my first term, times it with my second term, and times that by 2. So plus 2 xh, hx, however you want to write it. Plus, and then we square our h squared. And as we see, we don't have any like terms, so that is fully simplified f of x plus h. Now we can continue. And now remember, our formula says f of x plus h minus f of x. So now I'm going to go outside of the formula. You can do it inside the formula, but it really takes up a lot of unnecessary space. So I'm going to do it outside the formula. It just makes it so much shorter. So now I'm going to rewrite my f of x plus h that I got by the previous step. And now I'm going to minus bracket, after a negative comes a bracket, the entire formula of f of x. So 1 plus x squared. All right, so basically what happens is that negative times into the bracket, and then that becomes minus 1. So we have 1 minus 1, they're going to cancel. Then we have x squared times it in minus x squared. They are also going to cancel. And we are only left with 2xh or hx plus h squared. So here I now have my top step. I now have my numerator over here. So I didn't need to do it all the way inside of the formula. It just saves on space a bit. Okay, so now our notation is extremely important. I am now going to say the first derivative, very important, is equal to the limit as h approaches 0. We already have the formula, nay, f of x plus h minus f of x over h. So now let's just go substitute that in. Here is my f of x plus h minus f of x already calculated. So I am just going to substitute that into my limit notation over there. All right. So my next step is to factorize the numerator. If we have a look at the numerator, we have a common h. So I'm going to take that out. So I'm going to factorize, take out the common factor, and we are left with 2x plus h over h. And basically what happens now in this step is that this h and this h over there cancels out. They divide. H divided by h is 1. So there's no need to write the h and the h anymore. So continuing with my limit notation all the way, equal the limit as h approaches 0, equal limit as h approaches 0. It continues as long as I have to until I substitute 0 into h's position over there. So now that I substitute h is 0 into my formula, I can now drop my notation. So this is now just 2x plus 0. And what happens in this case is that the h falls away, plus 0, and we are just left with 2x. So this is deriving from first principle, the long method to do it. You only do this step when the question asks you to derive from first principles. Otherwise, we are going to look at our short methods that we'll do in a different video.